Hello and welcome to this walkthrough. I'm going to be going through a case called Pinball, which as you can see was from the 2023 season. I don't know precisely what round it was, whether it was a qualifier or part of the live competitions. This is being, well, 3 years before my time, having just started this year, 2026. It's an old style case in that there's 5 levels and 3 bonuses, rather than 7 levels and 5 bonuses. I haven't found, I didn't look particularly hard, but it wasn't immediately obvious that there were any walkthroughs already on YouTube. So there may be some out there and I've just missed them, but I thought, so I don't know if that's because whatever reason that is. But yeah, I thought I'd give it a go. Again, usual caveats. I'm doing this having solved the case a few times, worked out the best approach, learned a few things along the way, which is the main reason I'm doing this, because it helps me really think about what I'm doing and kind of get into the logic of the cases. So this is a developmental case. So I'm assuming if you're watching this, you've either attempted it or you're going to attempt it, where each level kind of builds on the next one, which sometimes is good, but it does mean if you get stuck on a level and you don't build a model that works, then your chances of getting points on the later levels becomes very, very low. So that can be frustrating in the heat of doing this. And when I did it the first time, I think I got to level 4, and then my model kind of broke down. There was just some bit of the logic and tracking that I just couldn't get my head around. And then taking time afterwards, I worked it out, and hopefully that's all going to work out well in this little walkthrough now. So I think I've said enough. All we really need to know is there's no other sheets to this. All you're given really is basically this table here, which tells you different bumps. You're given these nice icons, although actually they don't come in use at all. So you just need these numbers here and these points, and then an understanding of these rules or effects as they come through, although they're introduced slowly, so it's done quite nicely. So yeah, that's enough to say. Let's get started and start the clock for our 30 minutes, which we hopefully won't need, and off we go. So level 1, there is only one ball and there are no combos. The game lasts until the first bust, but no more than 31 bumps in total. Ignore special effects. So I'm going to start by going to this data here and adding this, giving some named ranges. So I'm actually going to change this from this hash symbol to bump, because when I now select this range, do Control Shift F3 and get my names from info, now got bump and points are all that I really need. And I'm going to model this out into a data table. And what I'm going to do is I'm going to take a 2col of B1 hash, which gives me all of my bumps. And then we want to know what the points score. And it's just going to be an X lookup on this range, searching in bump and returning points. Gives me my score, but we now need to know whether we have, how long do we keep going, because as soon as we hit this 10 here, that's a bust and we lose our ball. So we're going to keep track of how many balls we have, and I'm going to start on a 0 in the, I'm kind of thinking of this as what I have in the rack ready to go if I lose my current ball, because we obviously have one in play. So the rule is if this equals 10, then we take this and -1, otherwise we just return what was there before. We do that down, we then hit -1 after the 10, and we actually would lose even more balls later because there's another 10. But then we need to play into the fact, are we alive? Well, we definitely start off alive. We have lives left, so we'll start off on 1. But the rule is going to be here that if the number of balls drops below 0, then we're dead. Otherwise, we just continue whatever we were in the status above. And this has the handy effect of meaning that even if we, in later games, we can actually get balls back, we can earn balls, even if we came back above 0, this won't change our alive or death status. So it's only going to ever change once, which is useful. And then what I want to do, I want to filter the points where we are alive, so where this is true or equals 1. And that's all the points I would score, and I'm just going to wrap that inside a sum, and I get 175, which is what I should expect. And I'll take those values, go over to our score sheet, paste those in, and we get 60 points, so we're good. So let's go on to level 2. So in level 2, we're going to try master combos, and the way they did this, they just give you the first 3 balls to learn the logic, which is useful, but I'm going to build this in a way that kind of anticipate what comes up in level 3, just to keep it simple. From a learning point of view, I don't think that's going to do any harm. We're not doing this to try and be realistic for what's actually happening in the game. So we look back to the current the current bump plus the two previous, and we multiply where there are points. But if it was a miss, we don't multiply by 0 because that would obviously undo any work that we've done. So let's again build this as a data table, grab our logic from the first level, paste that into here. And you can see we only got those three, so let's just clear out some of this that's not affecting. And this isn't working because the ranges it's filtering is not the same. So on the old, without combos, this would be 115, but we need to get 1600. So let's add in an extra column and work out how many combos we're dealing with. So I use a bit of if logic when I first tried this, and it seemed to work. So what we're saying that if the previous bump was 10, then that resets our combo, so we can only have a combo of 1. If it wasn't 10, but the one before that was 10, then we can look back 2 or 1 plus the current row. Otherwise, actually, we can use all 3 in our combos. And now we're going to have to add in a new column to actually work out the points. So I'm going to build this as just a little let statement where I want to find the range, which is how many cells I'm looking back, and I'm going to say if this equals 3, then I want to look back at these 3 cells. If that equals 2, then I want to just look back 2 cells. Otherwise, just return the current row. And that's going to give me my range, which I'm missing something in the formula here. I think there's closed brackets needed there. And on this first one, it's actually giving me the 100, the points, and the 0. But actually, our formula is going to not worry about that, if that makes sense. Not explaining myself very well at all. Because what I'm going to do is I'm going to say I want to filter that range where that range doesn't equal 0. Because I want to ignore when we just miss something, and that's still keeping that points label in there, but that's still not going to matter because actually all I want to do is I want to multiply these all together, and when it multiplies, a bit like with the sum, it's just going to ignore text, so it's just going to say the product of 100 is 100. Now if I just fill that down, you think okay, that's good, and if I change the filter to return these points, but now I've got 1700 instead of 1600, and that's because on this second one I shouldn't actually return anything because I haven't actually hit anything. So I need to put a little bit more logic in here. So I'm going to say if and the bump is greater than 0, so it wasn't a miss, but it was less than 10, so it wasn't a reset, then we're going to have some points. Otherwise, we just return 0. And I think my brackets are slightly wrong there. So now when I fill that down, we get 0 on that, and we get our correct answer. So let's equal that. And let's copy our answers over to the score sheet. Paste that in, and 160 points. Good. Okay, let's go on to level 3. And in level 3, we now have the main extra bit of logic is that we can now get more balls. If we hit a 4, then the number of balls increases. So the game can potentially last longer because we're not necessarily out on our first bust. So we'll grab the logic from level 2. We'll paste it into level 3. We will grab all of these columns and shift them down. We'll also need to grab this logic, and just using this by hand, which is not the most efficient way, but just for learning purposes that works. So at the moment our score is not what's expected because we're not adding balls. So in the balls column we're going to say if it's a reset we take 1 off, but if E6 equals 4, then we take I5 and we add 1. Otherwise we do the same as before. So now we're going to see that the number of balls can change and go up, and that's now made our logic correct. And we'll refer to that cell, copy our values, go to the score sheet, level 3, job done. Okay, let's go to level 4, which is where it starts to get pretty tricky, where I got stuck doing this the first time. So now we have acceleration. So 2 turns on acceleration, 3 turns it off. And when acceleration is turned on, we can actually look back an extra combo. So our max combo goes up to 4. So we will firstly build a data table. and then grab our logic from the data level 3 model, copy that over and paste it in. So what do we need to do? We need to work out whether we have acceleration on. So I'm going to have a column here for acceleration. It starts off in the off status, and then what happens is we look at the row before, and if the hit before equals 2, then acceleration is turned on. If the hit before was 3, then it's turned off. Otherwise, we just maintain whatever was the previous status. And so when we fill that in, we see that, for example, here on the third one, we hit 2, so it comes on to the next round. We then hit 3, and it turns off for the one after that. And actually, by doing it this way, our combo simply goes up by, gets added by whatever our accelerator is. So when our accelerator is on, it can go up. But there's a little bit of extra logic we have to apply here because, and this is the bit where I got stuck before. Actually, no, sorry, let's sort out the points and then we'll come back because there's a thing we have to make sure we turn it off. So we now have the option that our combos might be 4. So I'm going to say if H6 equals 4, then the range we're looking at is these 4 cells. Then we carry on with the same logic as before. We fill that down. And the last thing we need to do is we need to say that, and again, this is where I got stuck a little bit before because we have to basically see that there's an option that acceleration comes on or off. Oh, that's the thing. So the acceleration turns off when we hit a 3, but it also turns off when we hit a 10 as well. So we need to add in here if or E5 equals 10 or 3 because the bust resets the accelerator. Okay, and then when we put that down, we get our answers and we copy that over to the score sheet and we've got our 220 points. Okay, let's go. How are we doing for time? 19 or 20 left. We've done 10, so yeah, that's fine. We're doing pretty well. So we will go to case level 5. Level 5 introduces a 2-player game. After player 1 busts, then player 2 starts his roll. After player 2 busts, then player plays again, provided that they have balls left, so provided they're still in the game. So we need to track both who the player is and also whether they're alive and in the game. So there's a little bit of work to be done here, but we can use our model that we've got so far. So let's grab our level 4 model, select all the columns, copy that, return to level 5 and paste that there. And then I'm going to add an extra column over to the left, which is tracking who the player is, and it always starts on player 1. And then what I'm going to do is I'm going to take, this is basically these things here, balls, alive, and the score. We've never actually labeled that score, but that's what that is, are what we need to track for each player. So let us grab those 3 columns and paste them here, and at the moment they'll be duplicated, but we're going to call this player 1 and this player 2. So there's still a bit of work to do because right now they're showing the exact same thing. So let's start with, which way around would we do with this? Let's basically, let's work out who the player is. So when is the player going to change? So if and this is player 1, but the bump is 10, so they bust, and player 2 is still alive, then we turn to player 2. If and previous player was 2, but the bump was 10, so there was a bust, and player 1 is still alive, then we go to player 1. Otherwise, we just stay with the same player. So let's close that logic, and we will then see we switch. So here we hit a 10, so it then becomes player 2. We then hit another 10, but player 1 by that point at the moment is dead, so we don't swap back. But we now need to get these to track only when we're dealing with the player. So our logic here says we lose ball if we hit a 10, but it actually needs to be if and the player is 1 and we hit a 10. And we gain a ball, again, if and the player is player 1 and we hit a 4. And only in those times does the number of balls change. The alive reference is referencing just that column, so we don't need to change anything there. The filter is also not correct because it's basically counting all points when player 1 is alive, but some of these points don't belong to player 2. So we need to add an extra filter condition here. So it's also when the player equals 1. We filter those points. Was that risky? Should I have accepted that? I think that is okay. And that's player 1 sorted. So player 1 scored 790. So this also needs to change, and also this is pointing at the wrong thing. So that is originally pointing at the bump. I should have probably locked the references so that we're looking at whether the bump is a 10 or a 4. But we then also need to add if and the player equals 2 and it's a bust, then they lose a score. And if and the player equals 2 and they get an extra ball, then it adds up, otherwise it stays the same. Again, the alive here is based on this. It's specific to just this column, so we don't need to change anything there, but the score needs to point at the actual points. And again, we need to apply that same logic to say we're only counting the points where the player equals player 2. And that looks good because we've got 1240, which looks to be the correct. So we only want to say the winning score equals the maximum of this or that. And when we put that into our model, into our data table, we get some calculation errors. So we'll look at number 71 and we go, right. So sometimes it's actually possible to get a 0. So what we'll say if error, probably means that we've got a 0 score. They didn't actually score anything. And that solves some of them, and I suspect this will solve the others, where I put the same thing around player 1. And all of our errors have gone. So we copy that, go to our score sheet, paste it, and we've got 360. So let's return halfway through, plenty of time, let's go through the bonuses. So the bonus number 1, what is the maximum possible number of points scored on a combo, including all the possible special effects? So the maximum number of points is 100, and we could potentially have 400s in a row. So if we just do the product of 100, 100, 100, and 100, we get whatever that is. That 100 million? I can't quite tell. I think it is 100 million. So we'll go to the score sheet and we'll post that in there. We'll come back and check if it's right in a minute because it takes a few seconds. What is the total amount of nominal points, not counting combos, available at all the 100 games, excluding the examples? So let us just add an extra sheet to do this. So I'm going to call a V stack, and then I'm going to grab all the points from all 5 levels, and just using the mouse here because it's a little bit quicker to find the next set of data, but then using the keyboard to quickly select it all and select that. And just in case there's any errors, not that there should be, in our call, so we use 3, and then I want to XLOOKUP all of those values in the bumps, returning the points, and then I'm just going to sum that range, and we get to 156735. We'll put that up in our bonuses, but we'll also put it into the score sheet. And we can see we did get question 1 right, and we'll come back in a minute to check question 2. And then assume there is an unlimited number of balls for a player on level 4. Assume that all the games on level 4 provide a continuous input, reading rows left to right for a continuous non-stop game that consists of 1800 bumps. What is the score of such a monster game? So we'll take our level 4 model, we'll make a copy of the sheet. We will then say that instead of looking up B1 hash, we're going to call from level 4. Is this level 4 here? Yes, it is. So let's select that entire range. And if we go all the way down, we see we're just over 1800 rows. So that looks good to me. So we need to just fill all the formulas down. We've got an unlimited supply. There's 1800 rounds. So the maximum balls we need is 1800. Probably not going to need nearly as many. And that keeps us alive the whole time. And that gives us our score. 259,15720, which will go up to here, And we'll also copy that to our score sheet. And we'll just wait a second or two to see if that is correct. It's not correct. What have I done wrong there? I thought I might have missed something. So we've got to filter where we're still alive. Ah, yes. Look, we didn't extend our range. So getting to cocky. So actually all I need to do, because we're going to be alive the whole way through, I just need to sum that entire range there. And we end up with a much bigger score this time. And this time, that is correct. And we'll put that back into our case here, just for neatness sake. But there we go. So that's all of that done in, let's stop solving early. So definitely achievable within half an hour. Even I suspect, again, I don't know exactly when this was, so I can't go and look at what the original score line was for players who did this. But with this case, I wouldn't be surprised if there were some players who managed to do it first time. Really good learning game, this one, actually, because just that developmental, each time building some more complexity into the model. Cell references, this you can see even here, although it gets really complicated on level 4, like this formula here is looking at kind of, there's 1, 2, 3, 4, 5, at least 6 different kind of references. So you can see how easy it is to get lost and point at the wrong thing. But yeah, although when I first tried this, I really didn't like it. Now that I've done it a few times and I see the neatness of it, I actually do quite like it, and it's very useful. And I think this is the first time I've really got my head around a 2-player game. There's a few, I think, like this, where a few cases I've seen where you have 2 players, and this is a really good one for learning how to deal with that and keep track and the sorts of things you need to do to always be checking which player is being involved at any one time. So yeah, I hope that was helpful. Even if it wasn't for you, it was for me. As I said, I only really do these things to help myself learn and get better, really. So that's the aim, and to learn stuff and to get better. So thanks for watching.